Hello, we've got a mixed operations problem today. It involves multiplication, addition, and subtraction all together. All right, if you want to try to solve this one out ahead of time, you go ahead and pause the video. We'll come back and work this one out together. It's not too bad. All right, remember your order of operations. Normally, when you look at a problem, you would first look for parentheses, or if you're familiar with BODMAS or maybe from the UK, Europe, you might be looking for brackets. Parentheses and brackets are basically looking for the same terms or the same grouping symbols here. Then you normally would look for exponents. Now we don't have parentheses and we don't have any exponents as well. We don't have anything like a factorial or square roots, anything like that. So we just skip it. This is probably the first thing that people will fail at when they do order of operations. They'll look and see, well, there's no parentheses, so I just go left to right. And that's the incorrect way to look at the order of operations. You basically just go down the list. Um, Parentheses are grouping symbols. Exponents are just shorthand for repeated multiplication. Then you go down and you look for it. Well, do I have any multiplication and division? And remember, multiplication and division have equal precedence. Well, in this case, yeah, we do have multiplication here. We do not have division. But if we did, we would just solve them left to right. Multiplication and division have equal precedence. And then moving on from there, step 4, we look for any addition and subtraction. Well, in this case, we have both. Now, thing to keep in mind here is addition and subtraction also have equal precedence. You can really solve them in any order, not just left to right. Now, there are acronyms out there. There's PEMDAS, BODMAS, BEDMAS, BIDMAS. They all mean the same thing. They just come from different English-speaking countries. And again, as I mentioned before, instead of using E for exponents, BODMAS uses O for orders. BIDMAS uses I for indices. They also use E for exponents. But again, these are just acronyms. They're just memorization tools, and they're not a complete understanding of order of operations. E is for exponents, but you could have factorials, which I'm not going to get into here. You could have square roots, which I'm not going to get into. Those all fall under that same category. BODMAS, where you have orders, same thing. And the D and the M shouldn't confuse you at all. Multiplication and division do have equal precedence and they're solved left to right. So the M and the D and the A and the S aren't really telling you that much. These are actually grouped together. Addition is not before subtraction. All right, enough of that. Um, we said we had multiplication, so multiplication is solved first. It's just shorthand for repeated addition. 2 times 2 is 4. 9 minus 4 plus 4 is 9. The negative 4 and the positive 4 cancel each other out here, so you're just left with 9. And I see a lot of people that will answer this problem and say it's 18 because what are they doing? They're taking 9 minus 4, getting 5. 5 plus 2 is 7. Then they're multiplying by 2 and getting 14, which is incorrect because they're blindly solving left to right, and they're doing the addition and subtraction before the multiplication, and that's never been correct. But you'll see a lot of people argue though. They'll say things like, "Well, gee, there are no parentheses around the multiplication, so you just solve left to right." Again, I covered that earlier. That's where people mess up order of operations. They look at the very first thing and they say, well, gee, there's no parentheses or brackets, so you just go left to right. Well, that's never been true. Multiplication already has precedence over addition. Now, I will say, a long time ago, a lot of teachers used to say, when you'd see a problem like this, they would say, go ahead and put your brackets, go ahead, put your parentheses around the multiplication. They would have you do that, but it was redundant. It wasn't necessary, but they were doing that to try to highlight the fact that the multiplication was first. Somehow that stuck with people in later years to think that, oh, well, if you don't have those parentheses, it means you must just forget everything and go left or right. Again, not true. Um, Multiplication is is repeated addition. It's kind of a long-worded way of saying it. From Merriam-Webster, they have a a little more complicated way of saying it, but they call it a mathematical operation that at its simplest is an abbreviated process of adding an integer to zero a specified number of times. So adding an integer to zero a specified number of times that is extended to other numbers in accordance with laws that are valid for integers. So it's really just a long-winded way of saying multiplication literally is repeated addition. Parentheses are not required to give multiplication precedence over addition and subtraction. But again, you'll see people argue, well, if we were supposed to multiply first, the multiplication would be written first. Well, it doesn't matter. It could be written first, but we don't know what this equation or expression is representing. The answer is still 9. 2 times 2 is 4, plus 9 is 13. 13 minus 4 is 9. It doesn't matter what order it's in. I could have the multiplication at the beginning, the multiplication at the end. It doesn't matter. And it's kind of the same thing when you think about a cash register or at a checkout. It doesn't matter what order the items are scanned at the checkout. The price is going to be the same. You're going to pay the same amount of money. So regardless of where the cashier scans the eggs first or the bread second or the milk third, it doesn't matter. The quantities are multiplied by the cost of each item. A cash register keeps a running total of individual cost and quantities and adds it up, it doesn't matter what order things are scanned. It's the same way here. It does not matter. I could have plus 9 minus 4 plus 9. The multiplication could be here. It could be on the end. As long as you're multiplying the same numbers and adding and subtracting the same numbers, the order is irrelevant here. You still get the same answer. But people will say, well, when I went to school in the 1970s, the answer was 14, or the 1980s, it was 14, or depending on how old the person is making the excuse, they'll say the 1960s, it was 14, or 50s, it was 14, 1940s, 1930s, whatever. And all those arguments are really fall flat. That's not true. It's never been true. Multiplication has always had precedence over addition and subtraction. And you can go back to a 1922 textbook here where it even gives examples. And it does say parentheses express a parenthesis expresses the fact that the quantities within the parentheses are to be taken as a group and to be treated as a single or individual quantity. 7 minus 2 plus 3 means that the sum of 2 plus and 3 is to be subtracted from 7, which gives the remainder of 2. Yes, if you see parentheses, you would do this addition first and then subtract 5 from 7. Easy. But if you have 7 minus 2 plus 3, you do not have parentheses. Well, all that's telling us is that 2 is to be subtracted from 7 and that 3 is to be added. The result is 8. So you get a different answer whether you have parentheses or not. The parentheses bring about a totally different result. And remember, even here, 1922, they knew enough. Multiplication and division signs take precedence of addition and subtraction signs. The first two signs, units, the numbers between which they're to be placed. So, as if they were in parentheses. And again, parentheses are not necessary. And they have an example with just division. 12 minus 10 divided by 2 indicates that 10 is to be divided by 2, and the quotient is to be subtracted from 12. So the division comes first, even though it's here. Same thing here. They give an example 4 plus 6 times 3. Well, it indicates that the 3 times 6 are to be added to 4. So you're doing the multiplication again first. I mean, they knew this stuff 100 years ago. I mean, this actually goes back to the 1600s or 1500s actually. There were early books in the mid 1500s which uh, began this whole order of operations, at least within Western civilization. Here's a 1950s textbook, the same thing. It talks about performing multiplication and divisions in order from left to right, and then finally do the additions and subtractions. And they do talk about if you have expression, simplify the expression within each order of inclusion, which they're talking about parentheses, and other symbols of inclusion. But in these examples here, they're doing the same thing. The multiplication is solved, then the addition is solved. 5 plus 3 times 2 is the same as 5 plus 6 or 11. So again, pretty simple stuff. A 1913 textbook. Yeah, it's an algebra book, but it doesn't matter because the order of operations applies to algebraic and non-algebraic expressions and equations. So they talk about addition, subtraction, multiplication, and division. And it says the indicated operations are to be performed in the following order. First, all multiplications and divisions in their order from left to right, then all additions and subtractions from left to right. Again, as I said before, when it comes to addition and subtraction, the order really isn't that important. 5 minus 2 is 3. Negative 2 plus 5 is still 3. So the order really doesn't matter. You can mix those numbers up as long as you don't change the signs, as long as you're keeping the negative sign in front of the 2, right? As an example. But the other thing, too, the other one of the sad arguments is you'll always have that person that says, well, my calculator says the answer is 14, so there. Well, it's because they're using a really cheap calculator, or perhaps they're using their Windows computer and they've got the calculator set in standard mode, which means that this calculator solves in what's called immediate execution mode. So as when you're typing keys in, it will actually solve each operation as you're entering it. So it's not keeping track of the precedence of what's inside of your expression. This is really meant more for adding, subtracting. If you do use this calculator in standard mode, you have to already understand order of operations, and you would have to do the multiplication first. You would actually have to do the 2 times 2 first. Um, and you see here that I typed in the same numbers on both of these calculators, whether I had it in scientific mode. In scientific mode, I typed in 9 minus 4 plus 2 times 2, and I got 9. I typed the very same thing over here. I typed 9 minus 4 plus 2 times 2, and I got 14. Because what happened is, when I type it in on this type of a calculator setting, it takes 9 minus 4, and then immediately solves it as 5, because it doesn't know that I'm trying to type in an entire expression. It's called immediate execution mode. So a lot of people will reinforce an incorrect answer because they don't understand how to use the calculator that they have. So you really need to understand how different calculator input methods work. So again, it's immediate execution mode versus expression mode. And I touched on this a little bit earlier, but I said multiplication is repeated addition. You can replace the multiplication with equivalent addition and still get 9 as the answer. Now, this one's a pretty simple example, but what is 2 times 2? 2 times 2 is the same thing as adding 2 times, right? It's kind of like saying, 5 times 2 would be the same thing as adding 5 2 times. So you can replace 2 times 2, in this case, with 2 plus 2. It's the same thing. 9 minus 4 plus 2 plus 2 equals 9. All right, so I know this has been a little bit in-depth on a very, very simple problem, but I wanted to try to touch on a lot of the confusions that people have. A lot of people get confused on order of operations. They believe that you read left to right as if you're reading a sentence, and you ignore order of operations. And that's never been true. So just wanted to try to reinforce that. Hope the video's been helpful. Please consider liking, sharing, subscribing, and look forward to seeing you in the next video.